Now, a small variation of the same program will be the following. If the manager of PEP zone wants the probability of a stock out during replenishment lead time to be no more than 5%, what should the reorder point be? Hint: given a probability, we can use the standard normal table in an inverse fashion to find the corresponding z-value. So this is what we're going to do to solve this problem. So in pictures, this is the problem that we are trying to solve. So we have the standard normal distribution. We know that the area to the right of certain z-score is going to be 5%, and we call that z-score z sub 5%. So the area to the right is going to be 5%, and then the area to the left has to be 95%. Okay, so we're going to use the table in an inverse fashion. Now we're going to find the area to the left to be equal to 95%, and we would like to find what is the z-score corresponding to the area to the left, 95%. So again, this is a portion of the standard normal table. Okay, so now remember I told you, right, in the first column and the first top row, right, we have here in the first column the first integral part and the first decimal place, and here in the top row the second decimal place of the z-score. But what we have in the body of the table are areas to the left of certain z-scores. Okay, so then what we need to do is we need to find the area equal 0.95 into the body of the table, and then once we know that, then we can now figure out what is the z-score that produces that area. Okay, alright, so now we're going to do that here in the body of the table. We would like to find the value 0.95. So notice that this is 0.93, right? It's increasing as we move along this row. So 94.41, 94.5, and we get to 94.95, and then we jump to the value 95.05. So what that means is that the z-score that we are looking for, right, is in between these two values, because 0.95 is actually the midpoint between these values. Okay, so what that means is that we need to look at the z-scores equal to 1.64 and 1.65 and take the midpoint between those two. Okay, so then the value that we are looking for is going to be 1.645, which is the value that will correspond to the area 0.95. So that's the first step. The first step is find the z-value that cuts off an area of 5% on the right tail of the standard normal distribution. Again, to find that value, right, we look for the complement, the 0.95 to the left, because remember, the standard normal table only gives you areas to the left or certain z-scores. So we find it here, right, as we described before, right, and that will be the value. So that's the z-score, right, the z-score. But remember, right, we don't want the z-score, we want the actual demand, right, not the z-score of the demand. So how do we get the demand? Well, now, in the second step, we need to convert the z-score into the corresponding value for the original random variable. Now, to do that, we have this formula here. So the value is going to be the mean plus the z-score that we just found times the standard deviation. Okay, now this formula here is just solving for x in the formula of the z-score. So we have the z-score, right, so that the area to the right is 5%, right, is going to be equal to certain value of the random variable that we don't know minus the mean divided by the standard deviation. But in this formula we know everything, right? We know the standard deviation, we know the mean, and we just found the value of the z-score in the table. So then we can solve from here to get this expression. Okay, we solve for x, we find this expression, and we know everything. We know mu equal 15, we know the z-score equal 1.645 that we just found in the table, we know the standard deviation c. So after doing these operations we get this value, 24.87. Okay, so since we want to have whole numbers, we round these up to 25. Sorry, 25. Okay, so then a reorder point of 25 gallons will place the probability of stock out during lead time at slightly less than 5%. Okay, so graphically this is what we just did, right? So now we know that in the original random variable, right, the mean is 15, the standard deviation is 6, and we know that this value here separates the standard normal distribution into two parts. One part to the left with area 95% and another part to the right with area 5%. Okay? So comparing the two methods, right? So by raising the reorder point from 20 gallons to 25 gallons on hand, then the probability of the stock out goes from about 20% to 5%. This is a significant decrease in the chance of the provided pet zone will be out of stock and unable to meet customers' desire to make a purchase. Okay. Now, all this that we have been doing here, it can be done also by using Excel. We can use Excel to compute normal probabilities, either real normal random variables or the standard normal random variables. So Excel has two functions for computing cumulative probabilities and x values for any normal distribution. So norm.dist is just to compute the cumulative probability given an x value, and norm.inf is just to compute the x value given a cumulative probability. Next, we are going to introduce the exponential probability distribution. So the exponential probability distribution is useful in describing the time it takes to complete a task. The exponential random variables can also be used to describe the time between vehicle arrivals at a toll booth, the time required to complete a questionnaire, or the distance between major defects in a highway. Also, in waiting line applications, the exponential distribution is often used for service time. A property of the exponential distribution is that the mean and the standard deviation are equal. The exponential distribution is skewed to the right, and its skewness is 2. Now, the probability density function of the exponential probability distribution is given by this formula. So the function is defined through an exponential function and is 1 over mu, then multiplying e to the negative x, and negative x is divided by mu, where x is a value which is greater than or equal 0. Here mu is the expected value or mean of the exponential probability distribution, and e is this number here, this a very important constant that we know how to use. Okay, so then the important property again here that we are going to be using is that the exponential distribution, for the exponential distribution, the mean and the standard deviation are equal. Now remember that the aim here is to be able to calculate probabilities or areas under the graph of this function here. So luckily for the exponential probability distribution, we have this function to calculate cumulative probabilities. So the probability that the random variable takes a value which is less than or equal x naught, where x0 is any specific value, it will be 1 minus e to the negative x0 divided by mu. And remember here, mu also is the mean and the standard deviation of the exponential probability distribution. So let's go straight to an example. Al's full service pump. The time between arrivals of cars at Al's full service gas pump follows an exponential probability distribution with mean time between arrivals of 3 minutes. Al would like to know the probability that the time between two successive arrivals will be 2 minutes or less. So Al wants to calculate the probability, right, that the random variable that represents the time in between arrivals is less than or equal to. Okay, so if we follow the formula that we saw in the previous slide, this will be 1 minus e to the negative 2 divided by the mean, and the mean is equal 3. Okay, so this is the formula that we need to evaluate to calculate that probability. So if we replace, right, those values into the calculator, right, following this line here, so we know that the probability is going to be 0.4866, so about 49%. Now, if you look at this graph here, this graph is the graph of the probability density function that you see here, okay, and what we are calculating is the area from 0 up to 2. So this is what this probability is, and this is what this formula here is calculating. Okay, so the relationship between the Poisson and the exponential distribution is as follows. The Poisson distribution provides an appropriate description of the number of occurrences per interval, and the exponential distribution provides an appropriate description of the length of the interval between occurrences. And with this, we finish chapter 6.